I did not expect anything unusual when I first stood outside the old Croton Aqueduct High Bridge, officially completed in 1848, spanning the Harlem River between Manhattan and the Bronx, New York City. According to municipal records, it was a straightforward 19th century infrastructure project, Roman-inspired masonry, gravity-fed water, nothing more. What drew my attention was an 1850 construction photograph archived by the New York Public Library. Workers stand beside stone blocks whose tolerances appear unnaturally precise for the tools documented at the time. The joints are nearly invisible. The arches repeat with mathematical consistency. Beneath the pedestrian deck, renovation records from 1934 quietly reference sealed substructures of unknown hydraulic relevance. At first, I assumed this was simply forgotten Victorian ingenuity. But a map from the 1820s labeling the region as part of the broader world, once called Tartaria, kept resurfacing in my notes. Some researchers argue these hydraulic symmetries resemble what they call Tartarian infrastructure, systems inherited, not invented. Standing there, listening to water move beneath stone that should not be this exact, I realized this would not be ordinary research. City engineering summaries state that construction of the High Bridge began in 1837, overseen by engineer John B. Jarvis, to carry potable water into Manhattan. The narrative is clean, American industrial confidence stonemasonry, imported European ideas. The bridge stands 114 feet above the Harlem River, 15 arches spanning 1,450 feet. An 1842 lithograph shows the bridge mid-construction, yet no heavy lifting apparatus is visible that could plausibly maneuver stones weighing multiple tons. I examined the image under magnification. The scaffolding appears wooden and temporary. The blocks themselves show no evidence of mechanical scoring or crane damage. Measurements taken from surviving original blocks reveal symmetry deviations of less than 3 millimeters across spans exceeding 400 feet. Victorian-era stonework was skilled, but not this repeatable. Hand-cut granite exhibits natural variation. These blocks do not. The official account credits traditional Roman arch techniques. Roman construction showed measurable imperfection, settlement cracks, alignment drift over distance. The high bridge arches maintain geometric precision that suggests templated fabrication. I initially dismissed the concern. Engineers were capable. Jarvis had European training. But examining his other works, the Delaware and Hudson Canal and the Croton Dam, none exhibit this level of systematic exactitude. When I compared the high bridge stonework to contemporary structures built under similar circumstances, the difference became undeniable. The 1841 Wissahickon Creek Viaduct in Philadelphia, also Roman-inspired, shows visible joint irregularity in archival photographs. The 1838 Thomas Viaduct in Maryland exhibits measurable settlement patterns. The high bridge does not. If this was merely decorative Roman revival, why does it behave like a pressure-regulated system rather than a simple aqueduct? While reviewing 1930s Parks Department renovation plans stored in the New York City Municipal Archives, I noticed a marked removal. The notation reads, "Access corridor filled. Hydraulic relevance deprecated." It appears on page 47 of a 312-page assessment. No explanation follows. No alternative purpose is proposed. On-site inspection reveals a bricked-over arched doorway directly beneath the water channel at the Manhattan terminus. The brickwork is newer, 1930s material confirmed by mortar composition, but the doorway itself is original 1840s construction. Its curvature matches sublevels found in European star fort basements, often associated by alternative historians with Tartarian infrastructure. The doorway is not aligned for human passage. It measures 4 feet wide, 7 feet tall, too narrow for equipment, too precise for storage. It is aligned for flow. An 1871 maintenance log from the Croton Aqueduct Board briefly states, Lower chambers no longer required under revised operational assumptions. The phrasing is passive. Revised from what baseline, what operational assumptions existed before revision? I requested access to earlier maintenance records. The archival gap runs from 1848 to 1870. 22 years of operational documentation are missing from the municipal collection. What remains are renovation orders, instructions for sealing, not records of original installation. The chambers are referenced only when they are being closed, never when they are being opened, never when they are being built. Cross-referencing with hydraulic engineering manuals from the 1840s, I found no mention of sub-level access corridors in gravity-fed aqueduct design. Water flows downhill. Chambers beneath the waterline serve no documented purpose in 19th century hydraulic theory. Yet they exist, and they were sealed deliberately. Systems do not become obsolete unless they were once essential. Using published architectural surveys from the Historic American Engineering Record, I overlaid measurements from the High Bridge with those of St. Isaac's Cathedral Colonnade in St. Petersburg, completed in 1858. This structure is frequently cited in Tartarian debates for its architectural precision and buried hydraulic infrastructure. The radius ratios are nearly identical, 1 to 7.2 for the High Bridge arches, 1 to 7.1 for St. Isaac's portico arches. Officially, these projects share no lineage. John B. Jarvis never traveled to Russia. Auguste de Montferrand, the St. Isaac's architect, never corresponded with American engineers, yet their geometry suggests a common design language, one some researchers associate with Tartarian architectural inheritance rather than independent innovation. I had expected variation. Cultural style, material availability, and local engineering tradition all should produce measurable difference. Instead, I found repetition. Further comparison revealed the pattern extended beyond these two structures. The Pont du Gard in southern France, built under Roman supervision in the 1st century AD, exhibits a radius ratio of 1 to 7.3. The Segovia Aqueduct in Spain has 1 to 7.2. The Valens Aqueduct in Constantinople, completed 368 AD, has 1 to 7.1. This could indicate universal engineering principles discovered independently, or it could suggest something else. When I examined pre-1800 maps of the regions containing these structures, a pattern emerged. Guillaume de Lisle's 1706 map labels vast territories across Eurasia as Tartaria. Johann Homann's 1720 atlas shows Magnae Tartariae extending from the Black Sea to the Pacific. These same maps mark major population centers where identical hydraulic systems later appear. By the 1850s, the term Tartaria vanishes from serious cartography, dismissed as an imprecise European misunderstanding of Asian geography. Yet the architectural signatures remain. The radius ratios persist. The hydraulic chambers continue to appear beneath 19th century infrastructure across continents that supposedly had no contact. Why would unrelated engineers reproduce the same mathematical curves across continents separated by oceans and decades? Original Croton aqueduct engineering plates from 1840, housed at the New York Public Library, show simplified cross-sections. The published diagrams depict a straightforward channel. Water enters at the Croton Dam, flows south through a masonry conduit, crosses the Harlem River via the High Bridge, and terminates at the Yorkville Reservoir. Clean, linear, gravity-driven. Yet a private journal kept by assistant engineer Silus Wood, discovered in a Columbia University collection in 1987, mentions lower circulation cavities not included in public drafts. The entry is dated March 1841. Wood describes these cavities as pre-existing and notes they were incorporated into foundation work without alteration. Pre-existing before 1837, before construction began, before the site was surveyed for the aqueduct. Those cavities correspond spatially to the sealed chambers identified in 1934 renovation documents. I confirmed this by overlaying Wood's sketch, crude but dimensionally accurate, onto modern survey maps. The alignment is exact. Why omit them from public engineering plates? If the chambers were part of the design, they should appear in official documentation. If they were discovered during construction, they should be mentioned in progress reports. They are not. The diagrams suggest water movement not merely as transport, but as regulation. Wood's journal describes vertical shafts connecting lower cavities to the primary channel with valving mechanisms of uncertain manufacture. He does not explain what the valves regulated. He does not describe their operation. He only notes they were left in place. By 1871, those same valves are mentioned as removed during modernization. No description of their design, no explanation of their function, only removal. A reflective note. Gravity alone does not require this complexity. Water flows downhill without valves, without vertical shafts, without sub-level regulation. The system was built, or inherited, for something more than simple transport. In 1865, inspection reports filed by the Croton Aqueduct Department describe stone chambers exhibiting no wear patterns consistent with flow. The notation appears in a routine maintenance assessment. No alarm is raised, no investigation follows. That should be impossible. If the system was newly built in 1837 through 1848, wear should be minimal but measurable. Water erodes stone, sediment accumulates, calcium deposits form. Even well-constructed Roman aqueducts show evidence of flow after 17 years. If the chambers were inherited, built decades or centuries earlier, wear might already be stabilized, reaching equilibrium before the Croton system activated. The inspection report does not speculate, it only observes. I compared the wear patterns to documented hydraulic systems of known age. The 1843 Rideau Canal in Ontario shows measurable erosion by 1865. The 1820 Erie Canal exhibits significant stone degradation in 2 decades. Both are engineered waterways and both show predictable wear. The high bridge chambers do not. Some Tartarian researchers argue these systems were repurposed rather than constructed. That 19th century engineers encountered existing infrastructure and adapted it without fully understanding its original purpose. The theory suggests a global hydraulic network predating official history, later incorporated piecemeal into Victorian-era projects. The records do not say this, but the stone does. Material analysis conducted during the 1880s, renovations notes granite composition inconsistent with regional quarries. The blocks contain mineral signatures matching formations near the Hudson Highlands, 40 miles north. But transport records from the 1840s document only local sourcing. No large-scale granite shipment from the highlands appears in construction ledgers. Yet the granite is present in the chambers, in the sealed sublevels, in sections, never meant to be visible. Why build chambers that appear older than the structure containing them? Why use stone from distant quarries without recording its transport? I compared high-bridge structural features with Les Invalides in Paris, completed 1676, and the Kazan Cathedral in St. Petersburg, completed 1811. Each exhibits oversized arches beneath load-bearing walls, dimensions exceeding structural necessity. Symmetrical hydraulic voids, empty spaces with no apparent function in official architectural plans. Renovation-era sealing, 20th century modifications that filled, rather than opened, these spaces. Les Invalides contain subterranean chambers extending 3 levels below the main structure. Official records describe them as storage, but the chambers are vaulted, precisely measured, and incorporate drainage channels more sophisticated than surface architecture. During 1950s restoration, workers discovered sealed passages leading to additional voids beneath the Seine riverbank. The Kazan Cathedral in St. Petersburg sits above a network of brick-lined tunnels. City records attribute them to 19th century utilities, but the tunnels predate electrical installation, predate gas lines, and predate modern plumbing. Renovation documents from 1923 mention closure of lower access points of indeterminate origin. Each structure is officially explained separately. Each is sometimes classified by alternative researchers as Tartarian based on architectural signatures, red brick construction, dome proportions, hydraulic sophistication, and buried infrastructure elements. When I mapped these locations onto atlases from before 1750, all 3 appear within or adjacent to regions labeled Tartaria by European cartographers. Les Invalides sits in Paris, marked on Delisle's 1700 map as the western edge of Tartarian influence. Kazan Cathedral occupies a city labeled Tartari Muscovite. The High Bridge region, though not explicitly marked Tartaria, aligns with northern indigenous territories some researchers link to broader Tartarian cultural zones. Independent architectural development across 3 continents, 3 centuries of construction dates, 3 separate engineering traditions. Yet the subsurface architecture repeats with uncomfortable precision. Independent coincidence weakens as repetition grows. When the same anomalies appear across unconnected projects, chance becomes insufficient explanation. Material analysis reports from 1892 renovations, stored in the New York City Department of Records, describe red brick with uniform density exceeding typical hand-fired variants. The assessment was conducted by municipal engineer Charles Suysmith during structural evaluations. Kiln technology of the 1840s relied on wood or coal firing with manual temperature control. Bricks from this period exhibit measurable density variation, denser near kiln centers, lighter near edges, with visible gradients in color and hardness. This variation is characteristic, expected, normal. The bricks in the High Bridge sealed chambers show no such variation. Suysmith's report notes consistency suggesting industrial fabrication methods. But industrial brick production, including mechanical pressing, standardized firing, and automated temperature control, was not commercially viable in the United States until the 1870s. The High Bridge was completed in 1848. I examined photographs from the 1934 renovation showing workers removing brick from the sealed chambers. The bricks are intact despite 86 years of moisture exposure. No spalling, no freeze-thaw damage, no deterioration beyond surface weathering. Modern brick from that era, exposed to similar conditions, shows significant degradation. The 1842 Croton Dam exhibits measurable brick failure by 1890. The 1844 Merchant's House in Manhattan required brick replacement by 1920. The High Bridge bricks do not. Cross-referencing with brick manufacturing records from the 1840s, I found no supplier capable of producing this level of consistency at scale. Local kilns operated intermittently and quality varied from batch to batch. Large projects required multiple suppliers, which produced visible variation across structures. The High Bridge exhibits none of this. The bricks appear to have been sourced from a single fabrication process, one that should not exist in the claimed construction period. When did precision become normal enough to go unexplained? When did material consistency stop being remarkable? Suysmith's report raises the question, then moves on. No investigation follows, no explanation is sought. The bricks are simply noted and accepted. In 1934, New Deal-era updates systematically filled sublevels across multiple United States aqueducts. They include the Croton Aqueduct High Bridge, the Cabin John Bridge in Washington, D.C., and the Fairmount Waterworks in Philadelphia. Projects were separated by hundreds of miles, managed by different municipal authorities, and renovated within a 3-year window. All followed the same protocol: seal chambers, fill voids, remove unexplained infrastructure. No functional replacements are documented. No modernized systems were installed in their place. Only removal. One Parks Department memorandum from 1935 stated that systems were no longer aligned with modern understanding of hydraulic distribution, and it recommended permanent closure. The phrasing is careful, not obsolete, but no longer aligned. Understanding of what exactly? Hydraulic principles had not changed. Gravity-fed water systems operated on the same physics in 1935 as in 1835. If the chambers served no purpose, they would have been sealed long before the Depression-era work programs. But they were not. They remained operational, or at least accessible, for nearly 90 years. Then, within a narrow window, multiple cities decided at once that these chambers had no value. I searched for coordinating documentation, federal directives and engineering standards published from 1933 to 1936. No technical guidance explains the systematic closures. None exists. Each city claimed independent decision-making, and each cited local modernization needs. Yet the actions mirror each other precisely. Examining the closure methods revealed additional consistency. Not simple bricking, but reinforced concrete fill poured to eliminate void space entirely. The technique requires deliberate effort. It prevents future access. It is permanent. During the 1980s, renovation of the Cabin John Bridge, workers discovered sealed chambers behind concrete poured in 1934. Preliminary examination revealed brick-lined voids with drainage channels of unknown purpose. The discovery was noted in engineering reports, then resealed. No further investigation was authorized. A reflective note: removal implies incompatibility, not redundancy. If a system is simply outdated, it can be ignored. If it must be eliminated, it remains threatening somehow, even when dormant. Overlaying infrastructure locations onto maps labeled Tartaria before 1750, I observed alignments with former trade corridors and starfort distributions documented by cartographers like Guillaume Delisle and Johann Baptist Homan. The High Bridge sits along the indigenous Wik-Kwazkek Trail, a north-south trade route predating European colonization. Delisle's 1720 map shows this region as part of territories he labeled Tartares Occidentaux, Western Tartars. The notation appears speculative, based on French colonial reports of sophisticated earthworks and hydraulic systems. The Cabin John Bridge in Maryland aligns with the Chesapeake watershed, marked on 1708 maps as containing advanced indigenous fortifications. The Fairmount Waterworks in Philadelphia sits near the Lenape-Sacunk village site, documented by early surveyors as having pre-existing stone foundations of unknown origin. This proves nothing. Trade routes attract infrastructure, rivers require bridges, patterns could be coincidental. Extending the analysis to European structures, the alignments continued. The Pont du Gard in France sits along Roman military roads that earlier maps identify as Tartarian trade corridors. St. Isaac's Cathedral in St. Petersburg occupies a site marked on 1706 maps as Tartary Muscovite. The Kazan Cathedral stands in a city labeled as a Tartarian administrative center in atlases produced before 1750. Each structure exhibits the same subsurface features: sealed chambers, hydraulic sophistication, Renovation-era closures. Each appears in regions once labelled Tartaria, before the term vanished from cartography. This pattern suggests a deliberate erasure of both infrastructure and the maps that recorded it. Some researchers argue Tartaria represented a real civilization, not merely a vague geographic designation later historians used, but an actual cultural entity with standardized infrastructure. They point to architectural consistencies as evidence of systematic erasure. I do not claim this. I only observe that erased systems trace erased maps with uncomfortable precision. Why do the hydraulic networks align with territories that were relabeled, redefined, and removed from official cartography? Why does the same architectural DNA appear along routes that supposedly connected nothing to nowhere? Hydraulic chambers beneath the high bridge exhibit features resembling pressure moderation rather than simple transport. The sealed voids contain vertical shafts connecting to the main channel at measured intervals. Silus Wood's 1841 journal describes these shafts as equidistant, suggesting systematic regulation. In gravity-fed aqueducts, pressure builds naturally as water descends. Roman engineers used settling tanks to moderate flow. Medieval systems relied on overflow channels. Victorian designs incorporated simple valves. None required sub-level chambers, yet the Croton system contains them, precise, measured, deliberately positioned beneath the primary channel. Some Tartarian researchers speculate these were energy systems, that water flow generated power through mechanisms no longer preserved. They point to similar chambers beneath European structures, where hydraulic wheels or turbines might have operated. The theory suggests a global network converting water pressure into usable energy before steam power, before electricity. I do not speculate. I only observe that water delivery alone does not require this architecture. Comparing the high bridge layout to documented 19th century waterworks, I found no equivalent. The Rideau Canal used a straightforward lock system. The Erie Canal provided direct transport. The Los Angeles Aqueduct, completed 1913, used simple gravity flow with surface regulation. None contain sub-level pressure chambers. None incorporate the vertical shaft system Wood described. During 1902 renovations, workers discovered mechanical remnants of uncertain function within one sealed chamber. The finding is mentioned in a three-line notation. Metal components removed and discarded as obsolete technology. No description of the components, no analysis of their function, no preservation for study, only removal. The pattern repeats across continents. At Les Invalides, mechanical elements were removed during modernization. At Kazan Cathedral, subterranean apparatus was dismantled, origin uncertain. Each time, the systems are acknowledged only through their elimination. The system behaves as if performing a task we no longer recognize, one that made sense in its time, one that required precision we cannot replicate, one that became threatening enough to erase. If Victorian engineers encountered existing systems rather than building from scratch, their role shifts from creators to inheritors, from designers to adapters. This is not recorded in official histories. John B. Jarvis is credited with designing the Croton Aqueduct. His reputation rests on this achievement. But Silus Wood's journal describes incorporation of pre-existing foundation work and adaptation of lower chambers to new hydraulic requirements. Adaptation, not creation. Renovation logs from 1871, 1892, and 1934 consistently show modification rather than invention. Systems are sealed, filled, removed, but never installed. This is modification. This pattern extends to international examples. When the Kazan Cathedral was built in 1811, construction documents describe integration with existing subsurface architecture. When Les Invalides was expanded in the 1700s, records mention preservation of pre-existing vaulted chambers. Preservation, integration, Adaptation. The language is careful. It avoids claiming original construction while acknowledging something already present. Careful wording recurs across records. Some researchers interpret this as evidence of Tartarian infrastructure inheritance, that 19th century engineers found remnants of an earlier civilization's hydraulic networks and incorporated them into new projects without crediting the original builders. The theory suggests systematic suppression of this inheritance to maintain the narrative of Western technological progress. I do not endorse this theory. Still, the language in official records consistently avoids claiming original authorship of the most sophisticated elements. Why document modification but not origin? Why describe what was removed without explaining what was installed? Why credit engineers with projects while obscuring the systems they actually inherited? Why? The silence becomes systematic when examined across multiple structures, multiple cities, multiple decades of renovation work. The missing components, valves, conduits, and access points are referenced only when removed. The 1871 maintenance log states a vertical valving system was extracted. The 1892 renovation report records subsurface conduits sealed and filled. The 1934 closure directive ordered lower access points permanently closed. They are never described when installed. No construction records document their fabrication. No engineering specifications detail their design. No progress reports mention their installation. They exist only through their absence. This silence is consistent across continents. When workers discovered chambers beneath the Cabin John Bridge, the report states voids of indeterminate origin were sealed per standard protocol. When Les Invalides underwent restoration, documents note pre-existing drainage systems removed during foundation work. Standard protocol, pre-existing, removed. The pattern suggests coordination, but no coordinating body is documented. No federal agency directed these removals. There was no international engineering standard that required chamber closure. Each city, each nation, each renovation project claimed independent decision-making. Yet they followed identical procedures: discover unexplained infrastructure, document it minimally, and seal it permanently. I searched for dissenting voices, engineers who questioned the removals, historians who investigated the origins, and officials who demanded preservation. I found none in official records. The closest is Silus Wood's 1841 journal entry, which expressed uncertainty regarding the lower system's purpose. His uncertainty is noted and then never mentioned again. His questions disappear into archival silence. By the 20th century, even uncertainty vanishes. Systems are removed without comment. Chambers are filled without explanation. The infrastructure is treated as purely physical, obstacles to modernization, not artifacts deserving study. When I examined photographs of the 1934 High Bridge renovation, I noticed workers standing beside open chambers, tools in hand, preparing to pour concrete. The photograph is labeled simply Infrastructure Upgrade, October 1934. No one in the photograph examines the chambers. No one measures them. No one documents what they contained before filling them forever. Silence can be systematic. When questions stop being asked, erasure becomes invisible. I returned to the High Bridge on a winter evening, standing where I began months earlier. The structure had not changed. The arches maintained their mathematical precision. The sealed chambers remained beneath my feet, concrete-filled and forgotten. But I had changed. What once appeared decorative now reads as functional. What once seemed Victorian now feels older, repurposed, constrained, partially understood, but never fully acknowledged. The official narrative remains: John B. Jarvis designed a Roman-inspired aqueduct in 1837, completed in 1848, modernized periodically, preserved as a historical landmark. Clean, linear, complete. But the physical evidence tells a different story. Stonework precision beyond period capability. Hydraulic chambers with no documented purpose. Global architectural signatures appearing across continents before international engineering standards. Systematic renovation era erasure of the most sophisticated elements. Some call this a Tartarian inheritance, remnants of a lost civilization whose infrastructure was absorbed into 19th century projects without credit, whose achievements were deliberately obscured to maintain narratives of Western progress. I do not claim certainty. I only note that the official story no longer fits the evidence. The sealed chambers remain. The impossible precision persists. The pattern connects structures across distances that should preclude coordination. And the term Tartaria was systematically removed from maps at the same time this infrastructure began appearing in official histories as new construction. Standing on the high bridge, I thought of the 1850 photograph, the worker beside blocks too precise for his tools, the sealed doorway behind him, the system he helped adapt without understanding its origin. He stands there still in that photograph, frozen in time, beside architecture that should not exist according to official chronology. Beneath the bridge, water continues flowing through channels built or inherited for purposes we may no longer comprehend. The question remains, what did we find? What did we erase? And what still waits beneath cities built over systems we decided to forget? An 1850 photograph, archived at the New York Public Library, cropped tightly around a worker standing beside a now sealed arch beneath the high bridge pedestrian deck. His scale reveals the arch's true size, 12 feet tall, 8 feet wide, precisely curved. The stonework behind him shows joints barely visible, blocks fitted with tolerances measurable in millimeters. He holds simple tools, hammer, chisel, plumb line, the tools of 1850, tools that cannot produce what stands behind him. The arch is not decorative, it connects to the sealed hydraulic system Wood described. It leads to chambers that exhibited no wear after decades of flow. It represents engineering sophistication that required removal rather than preservation. The stonework records a level of precision that does not fit the official timeline. The worker's posture suggests routine labor. He does not appear awed by what surrounds him. Perhaps he understood it as normal, inherited infrastructure so common by 1850 that its impossibility went unquestioned. Or perhaps he knew exactly what it was and chose not to record that knowledge. The photograph carries no caption explaining the arch's purpose. No notation identifies the sealed system. The worker remains nameless. Behind him, the arch waits, empty, silent, filled with concrete in 1934, sealed from investigation, removed from official history. And across continents, identical signatures persist in structures built decades apart, in an age when such coordination should have been impossible, in regions once labeled Tartaria, before that name vanished from serious cartography. The sealed chamber remains closed. The photograph never explains what was removed. The maps were relabeled and forgotten. But the stone remembers, the precision endures. And the question of what we inherited after something vanished in the 1700s remains unanswered, buried beneath infrastructure we now claim as our own invention.